Hi, welcome to our webinar, Introducing Helix, a new and better DVCS. I'm Steph Turner, and I'm a developer in the open source community here at Perforce. Thanks for taking the time to join us today. This DevTalk is going to introduce the new DVCS features in the Helix Versioning Engine. We're going to look at some of the common use cases, smooth the transition for existing customers, and provide some tips and tricks to help DVCS newbies get into the swing of this new and better workflow. So our presenter today is John Wilson. He's a product marketing manager here at Perforce, and he's also a web and Windows.net developer. This is a 30-minute webinar, and we're going to leave some time for questions at the end. So please use the Q&A window in your console to enter your questions, and we'll try to get to as many as we can. You can also use your Q&A window to report any technical difficulties you're having, and we'll try to get to those. There's also some resources that we've made available for you. You can check those out, and don't forget to tweet at Perforce. We're going to be sending a link to the recording of this recording to all the registrants by the end of the week, so you'll be able to get that, and you'll see all the answers to the questions. So enough for me, and I'm going to hand things over to John right now.
Thanks for that introduction. Good morning, good afternoon, good evening, whatever it is, wherever you are, welcome to the webinar. Before we get to the meat of today's presentation, let's cover a few introductory items, starting with the agenda. We're first going to talk about why you should care about Helix and its new DVCS features. It's not the first DVCS system on the market, but it distinguishes itself pretty sharply from other alternatives thanks to its advanced features. We'll talk about how to get started with Helix for the very first time, literally from ground zero, with installing the software and configuration tips to smooth your out-of-the-box experience. We'll look at how to get started with a new project, working solo, creating your own local repository, enjoying that great DVCS workflow developers appreciate, and we'll highlight some advanced features like cleaning up history before sharing your code with the world. Then we'll spend some time talking about the additional features for working with teams, things like narrow cloning, shallow cloning, fetching changes from others and pushing your own work. And finally, we'll leave some time at the end for a Q&A session, so feel free to submit your questions along the way. We'll answer as many as we can, and I'll follow up personally after the fact for the rest. So why Helix? Plenty of users already enjoy Git and Mercurial, so why did we create a new DVCS? The answer is pretty simple. Those systems were designed with a particular sort of project in mind, and a particular sort of user hierarchy. They're great at what they do, but as the seemingly ever-growing plethora of Git management solutions in the marketplace suggests, they fall short in various respects. We have a long history of building software that works for every sort of project, contributor, and organization, and we've brought that expertise to the DVCS arena. So unlike other systems, Helix DVCS features were built with the enterprise in mind right from the outset. So the individual developer can work disconnected, without a central server, and he can enjoy all the speed his local file system can muster while doing so. All the power of the Helix Versioning Engine is right there, including advanced features like the ability to clean up local history. And unlike Git, Mercurial, and other such systems, Helix is the first DVCS without limits on the number of files, the type of files, the individual file sizes. Helix doesn't choke on gigabytes of assets, so you won't waste your time monkeying around finding ways to store them outside the repository. And when that local project becomes too useful to ignore, it's easy to push it to a central server and share with others. Helix gives you cloning options like no other system. Narrow cloning, for example, lets you bring down only a fraction of a remote repository, something Git users have wanted for years. Shallow cloning lets you bring down only a limited amount of history, reducing load on the server and the local footprint on disk. Helix repo remapping technology even lets you move content around, rearranging into a different folder structure locally if needed for some reason. And of course, you'll enjoy these advanced features under the watchful eye of Helix's long-proven security. Security's kind of been an afterthought with other DVCS systems, but Helix gives you finely grained permissions for users and groups at the central server, and our new threat detection technology actually monitors logs with behavioral analytics, which let it detect, assess, and report risks before your valuable IP walks out the door. In short, Helix is the first DVCS that really does work for everyone, any contributor, any project, any team for any organization. So with that, let's talk about getting started, from ground zero, installing the software. Helix DVCS features were made available with the 2015.1 release, which is on our website for download right now. Now, installation has changed a little, insofar as you'll need to install the Helix Versioning Engine, our server software, on each of your client workstations. Now, that might seem a little counterintuitive at first, but it's not if you think about it. The great thing about DVCS systems is that they give you all the power of a central server on your desktop. So just as Git and Mercurial put that server code on your desktop, so to speak, so too you have to install our server software on your desktop as well. Now for Windows users, that means you need only install the Helix Versioning Engine, because that installer already includes the latest and greatest command line client. You're good to go. Non-Windows users will need to install server software and then install the command line client as well. We'll be simplifying that installation process moving forward, but Linux and OS X users should be aware of it now. And finally, if you have any shared servers you want to use with DVCS features, update those to the latest Helix Versioning Engine software as well. And that's it. Now, since we're talking about getting started with installation, there are a few bits of configuration information relevant to DVCS operations. But don't panic. They're few and they're easy to deal with. Oh, and server admins don't need to be skittish either. The DVCS features are not enabled by default. So don't worry about updating your servers. That's not some automatic gateway to users indiscriminately fetching and pushing code. Nobody can use those DVCS features with your shared servers until you authorize it, which I'll show you how to do a bit later. There are also a couple of local configuration settings, or P4 environment variables, that matter as well, and I'll show you these along the way. Like I said, it's easy, you'll see. Finally, a word about the details of the systems I'm using today as in order. I'm working locally with a stock Windows 8.1 client machine, and I'll be connecting to a shared server VM running Windows 2012 R2. Now on each system I've done nothing to prepare beyond installing the latest Helix Versioning Engine software and knocking a hole in the firewall at port 1666, which is where we connect, and then connecting with the command line client once just to make sure everything works. That's all there is to it. Getting started with the Helix DVCS features is really that simple. Here we can see a completely blank folder ready for a new project. Before we initialize a new local repository, let me show you a bit of that configuration information I was talking about earlier with the p4 set command. In particular, the p4 port variable points to a server that will be queried when I issue the following p4 init command. Now, that created our repository. And note how the output reports the case sensitivity settings. The Helix Versioning Engine is flexible in that it can be configured to preserve or ignore case as desired, but its defaults sensibly follow the lead of the operating system on which it's installed. That is, it preserves case on Linux, as Linux does, but ignores case on Windows and OS X as they do. This is a potential gotcha because transferring content between servers with different case settings isn't easy. So, when a new repository is initialized, Helix checks with whatever server you might already be using. That's why the p4 port variable is important. That's what we see in the output. It's making sure that you're already using a shared server, that your local repository is initialized with the same case settings to make it easy to migrate your content later if needed. So getting back to our new local repo, let's take a look at the files that we just created. Visible in that folder is a p4 settings file and a p4 ignore file. The former, if I type it, contains configuration information that will be used by the local repository. In contrast, the p4 ignore file, as we can see here, is a bit different. It contains a list of file patterns that should be ignored when executing commands. We don't have much content here at the moment, but I'll show you later how that can be very helpful given the usual DVCS workflow. Finally, if I list the hidden contents of our folder, we find a .p4 root folder that wasn't previously visible. And if we look at its contents, we can see that this is in fact where the data files for the Helix Versioning Engine reside, the repository's personal server files, so to speak. This should be familiar to users of other DVCS systems, for example, as it's our version of the .git or .hg folders used by Git and Mercurial, respectively. Now I'll copy some files into this folder so we have something to work with. What we have here is a simple C++ application, for sake of reference. The p4 status command lets us see what work we've done. And in this case, we see that all those new files are unversioned as yet. The p4 rec command, rec being an alias for the harder-to-type reconcile, is what lets us prep those files to be committed. The rec command in this case does what the git or mercurial add commands do, though as we'll see in a minute, it does a little more as well. Now when we run a Perforce status command, we see all the new files are ready for commit. So let's go ahead and submit those files as the first commit in a new project. That's all there is to it. A single command initialized a new repo, while the reconcile and submit commands put all that new content under version control. Other file operations aren't any harder either. Here I will delete the rather useless README file and make a quick change to the build batch file. I'll add a little comment. Another P4 rec, and you can see that the rec command not only adds new content, but it recognizes files that have been modified and recognizes files that have been deleted. Another submit, and we're good to go. Now before we go any further, let me highlight how useful the ignore feature really is. I've been surprised at how many developers don't even know it's there, but it's a real time saver, especially when using DVCS workflow that relies heavily on the reconcile feature. I'll quickly build the sample application and run it. As you can see, it just prints some text on the screen, and not even good text at that. But we can fix that later. For now, let's run a status command and see what we've got. All those new files are stuff generated by the build system, stuff that we don't need to version, but would definitely get included if I did a reconcile at this point. Build artifacts like that are effectively noise that can obscure the signal, the files you actually care about. So let me do a quick edit to the P4 ignore file. There. This new ignore file contains a longer list of stuff that we don't want to see. Things like object code, incremental link data, the resulting executable file, and so forth. And with this new ignore file in place, we can see how a status command now reports nothing to be done, because it's now ignoring all that build system generated noise. Now, clever developers might pick up on a problem. Because the ignore file ignores the ignore file itself, the system isn't presently versioning it. This isn't a problem when I'm flying solo, but it would certainly be a problem if I were working with a team. And that's foreshadowing, by the way, a sign of quality in literature, film, music, and even DevTalks. And I suppose it would be nice to version the ignore file anyway, just in case I screw up and delete it or something. Well, happily, we can temporarily suspend processing of the ignore file and add it alone to the work to be committed by using the -i or ignore argument with the P4 add command. There. A quick submit later, and now we've added the ignore file to our versioning. Having covered the most basic stuff, let's turn our attention to one of my favorite reasons to prefer DVCS workflow, namely, the ability to treat your local history as a first-order work product. Let me explain what that means with a question. How often have you submitted something to a shared server only to realize seconds later you forgot a file, or worse, screwed something up? Continuous integration systems are painfully humorless when it comes to our human foibles. They will mock you mercilessly in emails to the entire team when you break the build. Though to be fair, your colleagues will probably mock you anyway for grammar, spelling, or the simple fact that it took you 10 commits to get all the details right. Well, Helix lets you rework your local history until you're satisfied via the unsubmit and resubmit commands. I'm going to show you a couple of very common cases, though I should point out I'm only scratching the surface. So let's do a quick change and submit that work with a bad description. I'll add a little comment here. There. The P4 changes command lets you see all the work that's been submitted in the local repository, and we see that bad description right at the top. Fixing it is simple with Helix. I'll unsubmit the most recent change to the file I just edited using the P4 unsubmit command. Now I can start the resubmit process interactively using the -i argument, which means that it will walk me through each of the changes that need to be addressed one at a time and let me figure out what to do with them. Now, in case you can't immediately remember what the differences are between LMECR, cap R, SDBV, cap VAQ, you can use the handy question mark to get a list of what all of these things mean. Now, in this particular case, C is the letter I want because I just want to change the description. So I'll enter a C, and our editor is invoked, and we can come here and I can change the description to something a little more meaningful, trivial as it is in this case, and then merge the changes. Now, once again, we can use the P4 changes command to see that we fixed that bad description. This might seem like a trivial example, but it's arguably the #1 problem against which Git newbies beat their heads, the inability to change a commit description after the fact because it's part of the whole tree ID. Mercurial users have it a little easier, but Helix does it best. That was quick enough, so let's do one more. Let me make another edit to that same file. I'll delete the useless comment I put at the top, and I'll delete that second useless line in the text there. And then I'll submit that. Then I'll make another change to the same file. Only this time, I'll fix the spelling mistake. There. Using the P4 changes command again, I can see I've really got two commits there that were both correcting little things in the same file. And this gives me an opportunity to show you how the resubmit command can squash changes into a single commit, changes that really ought to be one commit, conceptually speaking. So I will use a slightly different unsubmit syntax. Now what that does is unsubmits every change numbered 4 or higher, and it reports that it has unsubmitted 2 changes for us. I can use the changes command again and see that in fact change 4 and change 5 are now shown as pending. I can also use the resubmit command's list option -L to see that I have 2 unsubmitted changes to correct. So that having been done, I'll start the resubmit process interactively using the -I argument. And since I again don't remember what all these letters mean, let's use the question mark. Looking toward the middle of the list, we can see that the A option will squash the first change into the next. So I'll choose that. And since we only have the one more to fix, and the comment or description will not be reflective anymore of the work we've done, let me change the description. And then merge and submit my changes. Now when we use the P4 changes command, we see that the changes are numbered 1, 2, 3, 5 because we squashed 4 into 5 and changed the description to something more meaningful. The ability to clean up history like that is one of my favorite DVCS features, and I have only scratched the surface here today. You can reorder changes, make additional edits, and do a host of other things. But for now, let's move on to the last pressing topic for working solo, sharing your code. Plenty of little side projects fail, but what if yours takes off? Or what if you were just doing work for an initial technical spike while your Perforce admins debated where the work should eventually live? Either way, you're going to need to share that work at some point, but the only place it exists right now is on your hard drive in the local repository. In that case, the push command is your friend, because the push command is what lets you push your content to another server. So let's try a P4 push and see what happens. Well, that didn't work so well, did it? Notice how it complained that the remote origin does not exist. Git users will remember that an origin is just a pointer that defines an external location from and to which new content may be pulled and pushed respectively. Mercurial calls it a path instead, but does basically the same thing. Well, Helix uses a similar concept that we call a remote specification, though our remotes are significantly more powerful than Git or Mercurial for reasons I'll explain later. For now, let's create a new remote so we can push our content to the server and name it origin. To do that, I'm going to invoke the command p4 remote origin. And again, we'll see that it conveniently provides us an editor where we can provide the details. Well, in this case, I've set up a server on another machine for the Helix Versioning Engine, calling it HVE. So I'll change that, and I want to change the mapping down below to tell it where to put my files. Now, in this case, we're not going to go through what all the details of streams are, but they're a Helix technology that makes it much easier. It greatly simplifies the process of branching and automating the flow of code. So I'm going to tell it to put my main stream, which is created by default when you initialize a new repository, and I'm going to tell it to map that main stream entirely under my depot to a new project folder. Having done that, that remote origin is saved, and I can always see what remote specifications are defined by executing the p4 remotes command. I can see the one that I have. So now that we've defined origin, let's try to do a push. Well, like the first failure, this one's deliberate on my part. Again, I'm trying to show you how to get started from ground zero. And if you're starting with an existing shared server, it's all too easy to overlook the new DVCS specific configuration settings. That error message tells us the server hasn't been configured for push. So let's look at the server's settings by using a command that will show us all of the administrative values. There. There are 3 new DVCS specific settings that don't show up here at all. So let me set them with a quick few commands to illustrate how to do this. There. Now with the settings defined, when we push, all of our content goes to the server. One more thing. Let's do a quick p4 changes command on the main.cpp file I modified several times. Because of our cleanup, it shows only 2 changes, revisions 1 and 5. But if I launch p4v and connect to my shared server, I can navigate to the new project and see that it shows the same 2 revisions, but with different numbers, 1 and 2 instead. That's because revision numbers aren't identical from local copies to remote servers, which is important to remember when using the unsubmit and resubmit features. Server admins should note that the push commands make it easier than ever before to copy content between otherwise completely independent instances of the Helix Versioning Engine. Now that we have our new project on a shared server, our teammates can get at the source and start working. And they can do this via the clone command. Helix supports a couple different ways of cloning, and I've chosen to illustrate the above because it uses a file specification, the -f argument, rather than a remote specification. Unlike other DVCS systems, Helix supports narrow clones, letting you get only the files you actually need. And a quick file log command on the main.cpp file we edited earlier shows that we got all of the revisions pushed to the shared server. Now let's illustrate another way of cloning. By adding the -m argument, I can limit the depth, the number of revisions that I get during my clone operation. Repeating the same file log operation shows that we got only the latest and greatest revision this time. No matter how you clone, you enjoy the same DVCS workflow as before. To illustrate how team members can work together, yet keep their own private branches separate, I'll make a new dev branch with the p4 switch command. Running the switch command again with the -l argument lists all the branches and confirms I'm now working on dev. Had I any work in progress, it would automatically have been saved when I switched to the new branch. Now I can make a quick change to main.cpp and submit. That's how easy it is to work in isolation on your own private branches. To return my work to the shared server, I'll need to switch back to my main branch first. Then I can merge the work from dev and resolve any conflicts. Since there are no conflicts, I can simply submit the changes and then push to the server. Switching back to the other folder lets us simulate what other users will see. We can get the new work by using the p4 fetch command. As we can see, the dev branch change is there. Using the fetch and push commands let team members pull each other's work and push their own when they're ready. It's just that simple. Finally, it bears mention that Helix is the only DVCS system that doesn't limit you in terms of the number of files you version, the type of data, or the amount. Quite the contrary, Helix DVCS users enjoy the same huge file support in which Perforce leads the industry. It's the first DVCS system you won't outgrow, the first DVCS for everyone, no matter what type of work or data.
Great. Thanks for that demo, John. So now we're going to take some Q&A. Remember, you can ask your questions in the little Q&A widget, and we'll get through as many as we can. So here we have our first question. Let's see. What if I don't want history being rewritten? We have pretty strict auditing requirements.
Yeah, okay, that's a good one. I used to work in the medical industry, and you have to preserve every line, every commit. You're not allowed to delete stuff, at least not on a shared server. So for people like that who are in that kind of situation, all the server admin has to do is make sure that rewriting history isn't allowed. Those 3 configuration settings that I showed you earlier that we had to put in place for the server to work, allow fetch, allow push, and allow rewrite, if you just don't allow rewrite, then you can't have shared history rewritten on the server. It's that simple. Next question.
All right. So for senior software developers on existing projects already using other DVCS tools like Git, what are the most attractive features of Helix? Things that it can do better for them that I can promote as an incentive to switch to Helix?
Thank you for that question. I think some of the obvious advantages over Git are, I think the rewriting of history is easier and safer with us than with Git. That can be a problem elsewhere. Anybody who has had to live through the problems caused by somebody doing a forced push and then trying to clean that up with the team will probably be happier with a Perforce system that won't do that for you. I also think anybody working with lots of files, with large files, or are worried about the size of the local footprint. Game developers, for example, often have a big footprint because of assets. Will be much happier because we don't choke on big files. You don't have to use third-party tools or extensions or hacks or add-ons to keep your content outside the repository. And we have some advanced features like repo remapping, and you could combine multiple remote specs to get only the head revisions of big binaries, but all the revisions of code. So I really think we have some features to offer that make us more attractive in Git to a wide variety of use cases. Great question. Next one.
All right, here we go. Thanks for the answer. So I've read that an equivalent of Git rebase will be included in a future version of Helix DVCS. Can you talk a little bit about how that'll work or whether or not it's still on the roadmap?
Yeah, technically we have something to work like a Git rebase now. It's not quite identical because we don't destroy history in quite the same way that Git does. I think given the technical complexities of that question, I'd prefer to follow up with that person individually to make sure I'm not shotgunning the wrong answer out there. As I understand it, expanding that feature is indeed on the roadmap. We sort of already have it in that you can, pull updates your comrades have made to your local repository. There's a special switch for the fetch command that we think is essentially equivalent to Git, but without quite as much history destruction. But it's obviously kind of a complicated answer, and I'd like to get back with that person personally. I think we might have time for one more, Steph.
Okay, this is coming in from lots of people here. Will there be support for this new DVCS functionality in P4V?
Yes, there will. I'm sorry to say that at the moment you can use P4V with your local DVCS repositories, but it's kind of a hack and you have to go through support, and not everything is lined up and perfect yet. We're working on that. As I understand it, there will be a new release of P4V in the not-so-distant future that will have much better GUI support with the whole 9 yards. And I think with that, we're right about out of time.
All right. Thanks, John. And thanks, everybody, for joining us. A link to the recording is going to be available by the end of the week. And we're going to follow up with all the questions that didn't get answered here, so you'll all be able to see those, and they'll be available for you. So thanks, and have a great day.